Alright, welcome to our first section in Unit 2, Section 3.1, where we're going to focus on radian measure. Now we've already been looking at radian measure with the unit circle. As you filled in the unit circle, we discussed the fact that if I'm in radians, I go from 0 to 2 pi radians to make a complete revolution around my circle. That half a circle is pi, or a little bit more than 3 radians, while a full circle is 2 pi, or just over 6 radians. Now we are finally caught up in our work in the book with what we have been looking at on the unit circle. So a radian, radians are useful to us you see radians all the time in theoretical math. Anything dealing with angular motion, a lot of engineering problems, science problems. A lot of these deal with radians rather than degrees, because when I'm working in radians allows my trig functions to have domains that are all real numbers instead of degrees. It allows my trig functions to have domains of real numbers instead of the angle measures. Okay. By definition, an angle with its vertex at the center of a circle that intercepts an arc, or we can also use the word subtends an arc on the circle equal in length to the radius of the circle, has a measure of 1 radian. So this shows us 2 radians, half a radian, and 2 pi radians. I don't know why it doesn't show us 1 radian. So let's go ahead and let's do our best in a circle. When we have this radius equal to our arc length that is subtended by the angle. So here I have my angle theta in such a way that r is equal to s, where s is the arc that is subtended by the angle. When r is equal to s, I have 1 radian. And that is given right here. In general, if theta is a central angle of radius r, and theta intercepts or subtends an arc length s, then the radian measure of theta is always going to be s over r. But when s and r are the same, when they're equal to each other, I have 1 radian. So s is the arc length that is subtended by the angle. So here, this is s, and in this case it's 2 times r, so this would be 2 radians, would be my measure for theta. Here, s, my arc length, is 1/2 of the radius, so this radian value for theta is 1/2 radian. Here, my angle theta goes all the way around 1 full revolution, so that is going to give me my 2 pi radians. This ratio, s over r, is a pure number. There are no units. Think about that as if I had a ratio of centimeters to centimeters, so if I had 2 centimeters compared to 4 centimeters, just like when we did in dimensional analysis, we can cancel out units. When we cancel that out, I'm left with 2/4 or 1/2. The units cancel out. So when I'm dealing with radians, they're considered pure numbers. It's not a unit of measure like feet or centimeters. So if I give an angle and there's no degree symbol, I assume that is in radians. Alright, converting between degrees and radians. A full rotation around my circle, 360 degrees, is equal to 2 pi radians. So if I look at, that's 0 to 2 pi. If I look at just half of my circle, right there, if the full rotation is 2 pi, that means a half rotation is pi radians. So half of that full rotation is pi radians. That means that from 0 to pi, there are 180 degrees, right? 0 to pi is the same as 180 degrees. So 1 degree is going to be pi divided by 180 radians. And 1 radian is 180 over pi degrees. Now these give us basically conversion factors, like with our like when we were doing our dimensional analysis. You know, we said that 12 inches is 1 foot, or I can say that 1 foot is 12 inches. That conversion factor is true whichever way I stack it. I'm going to stack that conversion factor the way I need it to end up with what I want. Alright, so when I'm converting between degrees and radians, if I want to start with degrees and end up with radians, I'm multiplying in the pi and I'm dividing out the degrees. If I want to start with radians and end up in degrees, I'm multiplying in that 180 degrees and dividing out the radians, the value of pi. At least that's the way I think about it. What am I multiplying in? Here I'm multiplying in the pi to end up in radians. I'm dividing out by 180 degrees. Vice versa going the other way. So those are going to be my conversion factors. Just like when we were working with dimensional analysis. And we will do some more dimensional analysis this semester. Okay, let's look at that next page of notes. Do a little bit of work with this, converting back and forth. Now, unless you are told to approximate, unless you're told to round, you're going to keep things exact, and you still need to simplify as much as you can. So we are going to keep our answers exact, and we are going to simplify as much as we can. I'm starting in degrees. I want to end up in radians. So I think, okay, I've got 108 degrees. I want to multiply in that value of pi, which is what shows up typically when I'm in radians. I need to divide out that 180 degrees. So my degrees are going to divide out. I'm going to end up in radians. Now that gives me 108 pi over 180. I'm no longer in degrees, and that's true, but that's not simplified. It's not in lowest terms. So I need to think about what I can divide out. I know that that's divisible by 2 because those are even. If I divide 108 by 2, I get 54, so I know it's also divisible by 4. So, you know, let's start there. Let's start dividing by 4. If I do 108 divided by 4, I've got 27. That's 27 pi. And 180 divided by 4 gets me down to 45. 45 is divisible, is 9 times 5, and 27 is 9 times 3, so they're both divisible by 9. If I divide them both by 9, I'm down to 3 pi fifths. 3 pi fifths. And that's in lowest terms, that 3 pi fifths. In fact, when I go looking, just nope, nothing in pi fifths shows up on my unit circle, so it's not going to be a special angle. Well, I should have known that from the beginning. I'm sorry, it's early while I'm recording this. 108 is not a special angle on my unit circle. I just got distracted. Okay, negative 135 degrees, 135 degrees. It doesn't matter if it's positive or negative when I start out. It's going to stay that algebraic sign, positive or negative. It's just that now that symbolizes that I'm rotating clockwise instead of counterclockwise. Same thing here. I've got a negative 135 pi over 180, and I need to simplify. Well, I know these are both divisible by 5 for sure. 135 divided by 5 gets me to 27. 27 pi over 180 divided by 5 gets me to 36. And once again, these are both divisible by 9. So that gives me a negative 3 pi fourths. This is a special angle on my unit circle, which I would have known by looking. A positive 135 is a positive 3 pi fourths over here in quadrant 2. If I were to rotate in a clockwise direction to get a negative 135, that would be a negative 90, and then here would be my negative 135. It would fall in quadrant 3, coterminal with 225, or 5 pi fourths. Alright, and then lastly, this one is already a decimal, so I can assume that I'm going to have to use my calculator and I'm going to get to round. I'm going to use my significant digits. I'm going to use the idea of significant digits. I see I've got 4 significant digits here. So I'm going to use 4 significant digits. Now I'm taking my degrees and I'm still using my conversion factor, pi over 180. Using my pi button, not 3.14, not an approximation for pi. So I've got 249.8 pi. I choose to hit enter and then divide that by 180. And I want to keep 4 significant digits. So 4.123, I've got a 9 and I need to round up. So that means when I round that, I need to round to 4.360 and keep that trailing 0 to have my 4th significant digit. That one is rounded correctly. Now I could say radians for all of these, but I don't need to. If there's no degree symbol, I know that I'm in radians. Alright, so we've kind of taken our time through that. Let's go back the other direction and let's convert radians to degrees. I know I'm in radians because there's a pi and because there's no degree symbol. So this time I need to divide out that value of pi and multiply in my degrees. So when I use my conversion factor, I'm flipping it and looking at it the other direction. This time, factor out common factors right there. Those pi's are going to cancel out for me so that I'm left with 180 times 11 over 12. Now, before I multiply these in, I'm going to see what I can do to simplify here. Is 180 divisible by 12? Yeah, look at that. 180 is 12 times 15. So 180 is divisible by 12. So that gives me 15 and 1, which is, my numerator now is just 11 times 15, and the pi's have canceled out. So 11 times 15 comes out to 165 degrees. Here I've got negative pi sixth. I'm going to use my conversion factor stacked appropriately. I know that my result is going to be negative. My pi's are going to cancel, and 180 is divisible by 6. 180 divided by 6 is 30. So 30 times 6 is 180. So what I'm left with is a negative 7 times 30, or a negative 210 degrees. And then finally, again, we are using our calculator. This time we've got 3 significant digits. So we've got 4.25, that's going to be radians. So we're going to multiply in degrees and then divide out that pi. When you plug that into your calculator, 4.25 times 180, and then I need to divide that by pi. I get 243.5 degrees, but we want to keep 3 significant digits. So that 243.5 degrees, we need to round to 244 degrees to keep our 3 significant digits. Alright, just to reinforce that radians and degrees are not the same thing, let me push my focus button here. Sorry, it takes just a second. Just to reinforce that radians and degrees are not the same thing, If no unit of angle measure is specified, then the angle is understood to be measured in radians. This is super important and very vital that you pay attention. This is 30 degrees. This angle theta right here is 30 degrees. This angle theta is 30 radians. So you see that we have rotated around and around and around and finally wrapped around and ended up down here in quadrant 4. 30 degrees and 30 radians are not coterminal. They do not look the same size at all. They are not in common. So if you leave off that degree symbol and we are looking at a radian value instead of degrees, it is not going to be what you expected it to be or what you intended it to be. So make sure that you're paying attention. I will count off if you leave off your degree symbol, because that is telling me that you're giving me radians instead of degrees. Now this is just kind of a good way to look through and compare it to our unit circle and start thinking about those approximate values for our radians. Of course, 0 degrees is exactly 0 radians, so we don't have to approximate that. 360 degrees is exactly 2 pi radians. And if we approximate pi, oops, that's the wrong spot. I jumped in my thought process. So 180 is exactly pi radians, which we always approximate pi to be 3.14. Well, if we approximate pi to be 3.14, we're going to approximate 2 pi to be 6.28. Alright, so let's go ahead and let's do our exact values. We're doing our special angles here. So we've got 0, 30, 45, 0, 30, 45, 60 degrees would be the other special angle in quadrant 1. And then we switch to our quadrantal angles, 90, 180, 270, 360. And you can see from your unit circle here what those exact values are in radians. 30 degrees is pi 6th radians. 45 degrees is pi 4th radian. So I'm going to talk about all of our 45 degree angles. Those places that are 45 degrees off the x-axis in any quadrant are our pi 4ths. 1 pi 4th, 3 pi 4ths, 5 pi 4ths, and 7 pi 4ths. 60 degrees is pi 3rd, exactly. 90 degrees is pi half, because it is halfway between 0 and 180, halfway between 0 and pi. And then down here we've got 270 degrees, so we've got 1 pi half, 2 pi halves, 3 pi halves, and then 4 pi halves would be also 2 pi radians. Okay, so that's our exact values for radians. Let's look at our approximations as we go through here. Halfway, well, let's do this. Pi half is half of pi. So if I'm going to take this 3.14 as my approximation for pi, then I'm going to say that half of that, 1.57, is my approximation for 1 pi half. So this is 1 pi half, 2 pi halves, 3 pi halves is when I add 1 pi half and 2 pi halves. So if I add my approximation for 1 pi half to 2 pi halves, I get 4.71, and then 2 times pi, 2 times that approximation is that 6.28. So let's see what these approximations would be. 30 degrees is about half a radian, 0.52. Pi 4th is going to be half of pi half. 45 degrees is half of 90 degrees, so I would need to take half of 1.57. So 1.57 divided by 2, that comes out to be 0.785. We're going to go ahead and round that to 0.79. Pi 3rd, there's a couple of ways we can get to this approximation for 60 degrees. We can multiply our approximation for pi 6 times 2, or we could take our approximation for pi and divide it by 3. That's going to round a little bit differently depending on which way I choose to do that. If I take my approximation for pi and divide it by 3, it's going to round to, if I keep 2 decimal places, 1.05. If I chose to do pi 6, that approximation times 2, I would end up with 1.04. That approximation is going to vary depending on which way we approach it. You're not going to need to worry about approximations for these values, except to think about, okay, where would an angle land if it's about this many radians? The most important approximations, you're going to need to remember, okay, pi half is about 1.57, pi is about 3.14, 2 pi is about 6.28. If you can remember how to work out, or work out that this is about 4.71 radians, so that if I tell you, okay, I've got this angle theta, and theta is 2.4 radians. Well, where is theta going to terminate? Where will it fall? 2.4 radians is between pi half and pi, so this angle theta is going to terminate in quadrant 2. So I know that, for example, because it terminates in quadrant 2, its x-coordinate is negative and its y-coordinate is positive. So cosine and secant values are going to be negative. Tangent and cotangent are going to be negative, but sine and cosecant are going to be positive because it's going to terminate in quadrant 2. That's one of the things that makes that important for us. You should learn these equivalences. They will appear often in the chapters to follow in that sense. You're going to need to be able to estimate where your angle is going to fall based on what the radian value is. Finding function values of angles in radian measure. Well, this is very simple if you've got your unit circle, or if you remember your unit circle. As I look at these 6 angles, I see that here I have a pi fourth angle. That's going to be one of my 45s. 3 pi fourths. 1 pi fourth, 3 pi fourths is that angle in quadrant 2, the 45-degree reference angle in quadrant 2. Well, my 45s all have the same coordinates for sine and cosine. The only difference is what's positive, what's negative. Well, in quadrant 2, x is negative, y is positive. Sine over cosine, that's going to give me a cotangent value. Oh, cosine over sine, because its cotangent is a -1 here in quadrant 2. 3 pi halves. 3 pi halves is a quadrantal. That's down here. So my cosine function value is 0. My sine function value is -1. Sine of 3 pi halves is a -1. The others I have to put a little bit more thought in. Let's look at this cosine of 5 pi 6. 5 pi 6, 6 pi 6 is pi. So 5 pi 6 is just going to be 30 degrees off of pi. So I'm at 150 degrees. 5 pi 6 is the same as 150 degrees. I'm in quadrant 2, so my cosine function value is going to be negative. What is the coordinate pair that goes with my 30-degree reference angles? Well, the x is greater than the y, so my x, my cosine, is square root 3 over 2. So that's a negative square root 3 over 2. Secant of 5 pi third. 5 pi thirds. Well, let's figure out where 5 pi thirds is. 5 pi thirds is over here in quadrant 4. It's the same as a 300-degree angle. We're in quadrant 4, so x is positive, y is negative. Secant is the reciprocal function of cosine, 1 over cosine. 5 pi third, that reference angle is 60 degrees. It's further away from the x-axis, which means my x-coordinate, my cosine coordinate, is smaller than my sine coordinate. So this time, cosine here would be 1/2. When I flip that to get secant, secant is going to be 2. And in quadrant 4, secant and cosine are positive. All right, let's come back around over here. Tangent of 2 pi thirds. Let's find our 2 pi thirds. 2 pi thirds is right here, the same as 120 degrees. We're in quadrant 2. In quadrant 2, my x, my cosine is negative, sine is positive, so tangent is going to be negative. Tangent is sine over cosine. 2 pi thirds is a reference angle of 60 degrees. It's 60 degrees away from that x-axis. So the coordinates here are going to be a negative 1/2 positive square root 3 over 2. And if I set that up as sine over cosine, I end up with a negative square root 3 as my value of tangent. We've already done the sine function value. Cosine of a negative 4 pi thirds. All right, so cosine of a negative 4 pi thirds. Well, let's think about positive 4 pi thirds. Positive 4 pi thirds rotates over here to my third quadrant. It's the same as a positive 240 degrees. So I went 180 and then another 60 degrees to get to positive 4 pi thirds. Negative 4 pi thirds is going to rotate clockwise. We'll rotate pi and then another 2 pi thirds. It's going to put us right here. So 2 pi thirds is coterminal with a negative 4 pi thirds. So I have these same cosine, cosine and sine function values because these angles are coterminal. So cosine of negative 4 pi thirds is going to be a negative 1/2. It's the same as the cosine of a positive 2 pi thirds. Alright, hopefully right about now you are congratulating yourself for all the work you did during Unit 1 on your unit circle and seeing how useful it's going to be able to have this at your fingertips and in your memory, be able to work through the circle and to remember what's on there, at least generally. If you memorize quadrant 1, then you can easily fill in the rest of the circle without a lot of stress. Hopefully at this point you're super confident with your degrees, you're getting comfortable with your coordinates, and now you are starting to plug in those radian measures. Go back and review our walk around the circle if you need to, just to make sure that you are confident with that moving forward.